This question is come from SMO2021 Senior section, question number 9. Given that Px is a quadratic equation, given that Pn equals to 1 over n squared for n equals to -1, 2, and 3. Now, suppose k is positive integer, find the minimum value of k such that Pk equals to 1 over k squared. Definitely we do not want k to be 2 and 3 again. This is an interesting question because we see that two curves intersect at two different points for integer value of x. For Px is a quadratic expression with unknown value of a, b, and c. Using this information, we can form three simultaneous equations in a, b, and c, and then we can solve it. But it may be a little bit messy. So we will transform these data into a new function called h, or let hx to be x squared px minus 1. Then we know that h equals to 0 if x equals to -1, 2, and 3. So with this, we can get x plus 1 is one of the factor, x minus 2 is one of the factor, x minus 3 is another factor. Now note that hx is x squared times px minus 1, and this is a polynomial of degree 4. And since this is polynomial of degree 4, then there should be another linear factor. Since we know that pk also equals to 1 over k squared, that means hk should be equal to 0. So we will have x minus k must equal to 0. And one more information that we have here is the leading coefficient of hx should be equal to k. So that's an a here. So with this, our target is to find the value of k. So now we can write x squared px minus 1 equals to a x plus 1, x minus 2, x minus 3, and x minus k. Just now we use the leading coefficient to get this is equal to a. In order to get a k, now we observe that there's no term in x for left hand side. So we may compare the coefficient of x. So from the left hand side, that is equal to 0. From the right hand side, after we expand this, in order to get x, so we have x and 1x and all constant, 1x and constant, 1x and constant, 1x and constant. So it will be equal to a. If we choose this as x, the other constant will be negative 6k. If we choose this x, the other constant will be 1. It is equals to 3k. If we choose this x, it will equals to positive 2k. If we choose this x, it will be equals to a positive 6. It means that 0 equals to a 6 minus k. And since a cannot be equal to 0, and therefore k must be equal to 6. Right. Now we look at this question again, and we find that this is interesting because the graph of y equals to x squared will be as such. Okay. And after we compare all the coefficients, we should be able to get what is the value of a, b, and c, and we should find out that this is the possible curve, where this is equal to 6, this is equal to 3, this is equal to 2, and this is equal to 1. And actually, this is 5. So you can see it in using GeoGebra, you can have a nicer graph on these two curves. Doing some calculation, you should be able to find out what is the value of A, B, and C as shown here. That's all for today's lesson. I'll see you again. Bye bye.